I got a fucking problem. I love bad bitches, that's my fucking problem. Yeah, I like to fuck, I gotta fuck.
So this is the concept video for differential equations. Now, differential equations are... Here, let me erase this for now. We'll get back to this. Differential equations are equations where we have a rate of change. So let's call this dy dx, y and x being y being some sort of dependent variable, and then x being independent variable. So we have some sort of rate of change, and this rate of change is going to equal some function, and it might be a function of x and y. So this equation says that our rate of change, how y changes with respect to x, is equal to some function of x and y. It depends on if x is the time or whatever. It depends on what time you're at, and it depends on what value of y, so whatever value we're measuring we're at. So to solve these at our level, we need them to be separable. And separable means that our f of x, y has to be able to be split up into some function of x and some function of y separately. So we need them in this form: dy dx equals some f of x times some g of x, or g of y. These functions need to be single variable functions. So from this we have kind of three different classes. So let's call this class 1. We have what they call pure time differential equations. I'll just call them DEs, and that's going to be in the form dy dx equals some function of x. And then 2, we have these things called autonomous DEs, and this is going to be where dy dx equals only a function of y. And then you have the third kind. I guess it doesn't really have a name. I guess you could just call it first order separable differential equation. So I'll just call it both. Sorry. So yeah, that's what we had before, just a regular separable equation. We have an f of x times some g of x. So how do we solve these? So how to solve? So for type 1, so for our pure time differential equations, what you want to do is we have dy dx equals our function of x, and we want to get all the things with y in them on one side and all the things with x in them on the other side. So we multiply dx over, we have dy equals f of x dx. So just like solving any equation, we're trying to solve for y in these cases, so maybe I should go over that. What it means to solve these equations is to find out what y is. What is this function? So if we want to solve for y, we're going to get y by itself, or y all on one side, and now if we integrate both sides of this equation, we'll get the integral of dy equals the integral of f of x dx. And if we integrate both sides, we'll get y plus c. The integral of 1 is just whatever the integrating variable is. And since we don't know what f of x is, we can't integrate this. So, and we can put this constant on the other side. I'll absorb it into this indefinite integral. So y of x equals whatever the if we integrate f of x, we'll get y of x. So that's how we do that. and then usually we'll have a set of initial conditions. So to get rid of that plus c, whenever we find it, we're going to get some sort of condition like y of a equals some sort of b. And then we're going to plug this in and solve for c, and I'll show you what we mean in the examples. So moving on to our second form, the autonomous, we have dy dx equals some g of y. So again, we're going to get all the y's on one side. So we're going to divide by g of y both sides. And if we integrate both sides, we get the integral of 1 over g of y times dy equals integral of dx. So 1 over g of y dy equals x plus some c. So without knowing what the function is, we can't really go any farther than this, but this all depends on what our g of y is, and after that we can solve for y. Sometimes we can't, and we'll see how that works. And then for a third case where we have both, we're going to have dy dx, and we're also going to have initial conditions for these. And I think it's better to see those in examples, so we'll leave that for that. So we have dy dx equals f of x times g of y, and like before, we're going to get everything with y on one side, so we divide both sides by g of y, multiply both sides by dx, and now we integrate both sides, and we have the integral of 1 over g of y dy equals the integral of f of x dx. And without knowing what y and x, g of y and f of x are, we can't really go farther than this. So that's pretty much how you solve these equations. I don't think this is the hard part. The hard part sometimes is the integration and applying the initial conditions. So we'll get to that in examples. But this is the main idea, and I'll see you next time.